working.
Hello, everyone! Chapter 8, Series and Sequences, Learning Target 2. This is Miss Ozier.
And Miss Lahart.
And here we go. So, summation. It's a big old E, but it doesn't mean E. It means sigma, but it also means summation. So basically, if I had a sequence and I wanted to know how much all 50 terms added up to, you could use this to tell me. So this is what it looks like.
Okay.
It kind of looks ugly here, but I swear to you, it's way easier than this.
So, you will always, on the bottom of your sigma symbol, have an index variable. So they'll give you a variable. It could be any variable. This one, in case, is I. And then it'll be equal to a number.
So like A could be 2, A could be 3, A could be a number, a whole number. And then N is another number where you stop, so the last term you want to get to.
Right. So those numbers stand for terms. Starting value, and so ending terms.
Boom. Start value, end value.
Okay? All of those right there are all, like, the terms added up.
Yep. So let's show you what we mean here. So K squared is like the function that we're putting into, if you want to call it a function here. We are going to put -1 as our starting value, and then not just 3, but every number up to 3. So function's K squared, -1 squared is 1, so that goes in. 0 squared would be the next number, 1 squared would be the next number, 2 squared would be the next number, 3 squared would be the next number, and now I'm stopping because that's where it tells us to stop.
And now summation means you add those up.
Summation.
And then, so that adds up to 15.
So look at that. All that means is all of those things added up. Boom. All right. Next one.
And they can look uglier and uglier. We can give you whatever function you want. You'll see some weird ones.
So our starting value is 1, ending value is 3. So that means 1, 2, 3. Well, 1 plus 1 is 2. 2 plus 1 is... Oh, there's a number on the outside. I'm like, where did 6 come from? 2 plus 1 is 3. Times 2 is 6.
So in for I, we're plugging in 1, then we're plugging in 2, then we're plugging in 3.
And then we're adding them up.
And then we're adding them up.
Oh my goodness, this is such a hard learning target.
Okay?
That
Well,
was
it's an
called
exponent this
sarcasm.
time.
You guys can handle it.
But we're going 1 through 5, so we do have a couple terms. But, you know, sometimes you don't need to do all of them.
So when you raise -1 to a power, it's either going to be -1 or +1. If the power is even, it's going to be +1. If the power is odd, it's going to be -1. So that's where we just kind of plugged in because we knew the pattern.
I think my animations are off. I guarantee you I probably filled them out.
Well, you know, it's there.
Maybe.
Okay.
Maybe I didn't.
You got it.
Oh, okay.
But so, right, this pair is going to cancel, this pair is going to cancel, so we're left with a -1.
See, there they are.
Oh, they are there. You're right. Okay. I thought we were just noticing a pattern.
All right. So then the other thing we'll have to do is we give you a sequence, and you have to write it using summation notation.
Now here they're telling you to use I as your index variable. Yes, that means you have to use I.
Let's hope I used I.
If not, you know, it'll be like a 3.5, and it's okay.
All right.
Oh, I see an I. Okay, so we're seeing that these are all perfect squares, 9, 16, 25, and 100. The ... doesn't mean that like we just skipped it. It means all of those are still included. So that means 3, because 3 would give us the output of 9.
Yep.
And then what would give us an output of 100?
10.
10. So 10 is our end value.
There you go.
Boom.
Okay. So that was just, sometimes the pattern is very simple. It's a, you know, beautiful, perfect square. But sometimes you need LT1, which use your series and explicit formulas, and it's pretty simple.
So here I see a pattern. I'm definitely adding 3 every time, but I'm not sure what my equation should look like. So I use my arithmetic sequence, right? Yes, making sure I'm using the right words. My arithmetic sequence formula. I distribute my 3, etc., etc. So now 3n minus 9 is my formula. So I use my summation. I switch my variable to I because of just directions, no other reason. And then I put my start value and my end value. Because again, if we're making this equal -6, I would have started with 1.
Okay.
And you can work backwards.
So we're trying to figure out what our last term number is. So 15, I'm just going to set it equal to 3n minus 9 and see what n equals, which is 8.
Boom. Look at us go. Okay.
So there is some work required for this.
A little bit.
Ooh.
All right. Fractions, get over it. Okay, if you don't like the fractions, look over here. Okay, that's +4. Well, I don't think I'm going to get up to 625, and I don't think 1 minus 4 is a fifth. So this means probably it's a geometric sequence. So then I'm going to do 5 divided by 1, 1 divided by 1/5, 1/5 divided by 1/25, and I'm going to get my rate of 5. So then I'm using the geometric sequence. Boom.
Plugged it in. All right, now we need to figure out our index number. So I have I is going to equal. So we used a sub 1, so you're always going to have 1 down there. Okay. So 625, you could probably think your way through it, but if not, you can set it equal and just kind of solve your way backwards.
So 625 is equal to this. Divide the 1/25th over.
Ooh.
And
Common
then
bases.
You're gonna need to get common bases or
Aw.
log, or do your log,
No, I think
rewrite
I
it,
did a log.
and use your calculator. That works too. But either
Yes.
way, you get 7.
Boom.
Math it up.
I think that's it. Oh, no, I got one more.
No, one more. Hey, the answer's 2, guys.
All right, so this one. So you would just kind of plug in all the numbers to see which one gives you your sequence. Obviously, we're just going to look at 2 because you know the answer is 2.
Yep.
If I plugged in 0, I pop out 3. If I plug in 1, I pop out 6. And then that's the only one that matches up to get you to 48.
And that's how you do something like that.
Way to ruin it. Oh, I did do
That's
some work.
wrong.
Yeah.
Well, there's some work for everybody.
So I was just making the sequences. Oh, there
There
it
we
is.
go. Okay, and that's it. Have a wonderful day. We will see you in class where you will summation your little hearts out.
Summation notation.